Good morning, evening, afternoon, middle of the night, whatever. Let's start by getting logged into Clever. Here is your warm up question. Big debate. Are hot dogs a sandwich? Why or why not? I don't know. I think that it's a meat with condiments in between a piece of bread, so maybe it is. Welcome to week 12, lesson 22. We are going to continue to go over atoms, ions, and isotopes to keep moving us through this periodicity unit. So some reminders, check your assignments from previous weeks for comments, for grades, for returns, for requests. There was a couple of assignments last week that kids, some of y'all maybe did partially, didn't do completely fully. And so I returned it to you with partial credit. If you do it and return it back, I will give you full credit. Also, pay attention to Infinite Campus. We are getting almost to the point where it's the end of the 6 weeks, and I have to start finalizing your grades. I have not been putting in missings or zeros for any assignments yet. So if it's not turned in right now, it's a blank. So your grade is kind of artificially raised a little bit, but I am going to have to start putting those in. So if you see your grade drop, that just tells you that there's some work and some assignments that are missing that need to be made up. Go back and do them. I will change that as soon as as that grade comes in is updated. Make sure that you're doing the ed puzzles. So as always, the assignments, the ed puzzles that are posted on Mondays are required. They have a number in front of them. If it has a number in front of it, like the assignment that goes with this lesson, it is required. The lessons, like what you're watching right now, this is not required if you were in the live lesson. If you weren't in the live lesson, then this too is required. Remember our expectations. And remember again that I am super grateful for you guys being here, for putting in the effort and really being awesome and giving your best effort. So this week we are continuing to talk about atoms and the differences between atoms, ions, and isotopes. We're going to move into then at the end of the week, starting to look at how these elements are organized in a thing called the periodic table based on patterns and their characteristics. So there are 2 assignments that you're going to get assigned or that you should do and complete after we have done this lesson together. And then next on your next lesson on Thursday, there's another 2 set of assignments for you guys to look at. Again, remember this pattern of how you can make sure that you're doing your work when you need to be doing it. You have the content and the information to allow you to do it. So you previously should have watched the week 12 preview, number 50. You should now be here watching this live lesson. After you do this live lesson, then you want to go try and do number 51 and 52. If you have not watched this lesson and have already tried to do those, it's probably really hard. And then you'll watch the second lesson of the week, lesson 23, and do the last 2 assignments, number 53 and 54. It's a good idea whenever we're in this periodicity unit to have your periodic table up. So please open that in the link now. All right, and let's start with this as our warm-up. So reviewing, how do we use the information from the periodic table to find our protons, electrons, and neutrons? Super. So what you should have found is that the atomic number is 16. That's this number at the top. The atomic mass is 32. Protons are 16 because the protons are the same as the atomic number. The electrons, for now, are the same as the protons. And the neutrons, you take 32 minus 16. All right. So now let's build our Bohr model as best we can here in this ed puzzle. Great. So here's what your Bohr model will look like based on how you just described that. So your protons and your neutrons, 16 and 16, go in the nucleus. In your first shell, you can hold up to 2 electrons. We have to get up to 16. So if I put 2 there, I'm not done. Then can go to the second shell where I can put up to 8. 2 plus 8 is 10. I'm still not done. I can put 6 in the third shell to get us up to our 16. So this is what a sulfur atom looks like. All right. So now we're starting to differentiate between isotopes and ions and atoms. There's some slight tweaks that take place between each of these. So we started last week by me introducing to you the idea of an isotope by comparing these 2 isotopes of each other. We noticed that they have some similarities. They have the same name. They're both beryllium. They have the same number of protons. They have the same number of electrons. And then what we notice is different is that their mass is a little different because the neutrons are not the same. This top one has 6, the bottom one has 5. And the top one is also unstable, whereas the bottom beryllium is stable. So what these represented were isotopes. They're both the same element, both beryllium, but they have different numbers of neutrons and therefore different masses. We talked about last week then about some different ways to annotate or to show this. So one way is to put the symbol, and then in the top left corner you put the mass number, and then in the bottom left corner you put the atomic number. All right, so that's the mass, that's the atomic number. Another way that you might see this visualized is by putting the symbol or the name with a dash and then a number with that number representing the mass. So if you look over here at that carbon 14, it says underneath there carbon dash 14. Carbon is the element, 14 is the mass. Okay. And so with isotopes, the big things that we're figuring out are the neutrons and the mass number, dependent on what type of isotope this is. Isotopes are, again, elements, the same element, the same atom, except for the neutrons have changed, which means the mass changes. All right, so you're looking at our example we just did before with our sulfur. Here's what a normal sulfur atom looks like. Now, if we're talking about the sulfur isotope sulfur 35 that is listed right here, what automatically changed, this 35, tells you the atomic mass. If that atomic mass changes, that means our neutrons are going to change as well. So instead of it being 32 minus 16 to figure out our neutrons, it is now this mass, 35 minus 16, and that equals 19. Now, the only thing in our atom that actually changes is in the nucleus, instead of 16 neutrons, there are 19 neutrons. All right, so this is what the sulfur 35 isotope looks like. So let's try this using this information. What is the atomic number, mass, protons and electrons and neutrons of this particular isotope? Great. So what we should have gotten, the atomic number is this bottom number 9. The mass is 22. Our protons are the same as the atomic number, so 9. The electrons are the same as the protons for now, so that's 9. And then the neutrons, it's this new atomic mass, 22 minus 9. So the neutrons are 13. Okay. All right. So check these check for understandings. What is the mass of an atom with 7 protons and 8 neutrons? The correct answer is 15 because the protons and neutrons add together to tell you the mass. What about this? What is the element symbol for this same atom that has 7 protons and 8 neutrons? Great. So 2 ways that you could write it. You could put that atomic mass up here in the left corner, or you could put a dash and put the atomic mass next to that. So next we then went in to explore what exactly is an ion. And again, we looked here, we saw that there are some things that are the same. The beryllium, the type of atom is the same, the protons are the same, the neutrons this time are the same, and they're both stable. But what's different is that one is a neutral atom and one is an ion. And what we notice of why this is an ion, up here, this top one, the protons and the electrons are 4 and 4. They're equal. They balance each other out. In this bottom one, there's an imbalance. There are 4 protons and 2 electrons. So there are 2 more electrons, or 2 more protons, 2 more positive things than there are electrons. And that's why it has this positive 2 charge here and is a positive ion. So what an ion is when you have a charged atom because there are different numbers of electrons from protons. They don't balance out, okay? If there are more electrons than protons, it is negatively charged. Remembering that electrons are negatively charged particles. If there are less electrons than protons, or in other words, more protons than electrons, it is positively charged. All right, and the way that we symbolize this is next to the atomic symbol or the symbol of the element, in this case, He or Mg. In that top right corner is where you're going to put the charge. It's going to have a plus or a minus because it's either going to be positively charged or negatively charged. And then the number represents how much that imbalance is. All right, and with ions, what's a little bit tricky is that we have to kind of change our thinking. So to get a positive ion, you have to take away electrons. And that seems counterintuitive because usually when you take something away, that makes it more negative, right? You lose something. But if you take away negatively charged electrons, it's like eliminating that negative boyfriend or girlfriend or friend from your life. You get rid of them, you are left feeling more positive, right? So if you take away those negatively charged electrons and you get rid of them, then you are going to be left more positive. If you add those negatively charged electrons, then you become more negatively charged. All right, so looking at our sulfur example here, if it is an S minus 2, what that means is that there are going to be 2 more electrons than there are protons. So you can never touch the protons because the protons are what make this sulfur. But you can change the number of electrons. If this is negative 2, that means that there are 2 more negative electrons than there are protons. So instead of there being 16, there has to be 18. And all that means in our image over here, our Bohr model, is that we are adding 2 more electrons so that there is a full outer 8 in that shell. 2 plus 8 is 10, plus 8 is 18. This is what a sulfur ion will look like. All right, so let's go through the same process here for this particular element. Great, so our atomic number is 9, our atomic mass is 19, the protons are 9, our neutrons are 19 minus 9. The charge, because it is -1, that should tell you that there is 1 more electron than there are protons. And if there's 9 protons, 1 more than that would be 10. So there should be 10 electrons, and this is absolutely an isotope. All right, check for understanding again. If an atom has a charge of +2, are there more protons or electrons? That positive charge tells you that there are more protons. Protons are positive. If an atom has 34 protons and 36 electrons, what will its charge be? Great, it will be -2. All right, it's important to remember when we think about each of these, the atoms, if you're talking about 2 different atoms, they have different numbers of protons. If you're talking about 2 isotopes of each other, they're the same atom, so same protons. They just have different numbers of neutrons and masses. If we're talking about ions, again, it is the same atom. The difference is the number of electrons, okay? So how are we feeling after this? Did this help today? I sure hope so. So you're walking out of here with these 2 new assignments, number 51, isotopes and ions Edpuzzle. If you're still confused after this lesson, hopefully this will kind of help you out and fill in some of those gaps, as well as you have a reflection question, are all atoms the same? Remember these 2 assignments should be completed now that you've done this lesson. You can find them there on your Google Classroom. All right, please don't be afraid to ask questions, and I will see you next time. Hope you're well. Bye. Good luck.